Have you ever wondered what's inside the Earth that you stand on every day? You must be very clear there is just a sheet of sand and water. Yes, you are correct, but not really, because you are just known to the 1% of the Earth's structure. So, let's dive into the left 99%. Imagine the Earth as a giant, tasty layered cake, but instead of chocolate and vanilla, it's made of rock and metal. Let's uncover the Earth's mysterious layers. Starting at the very top, we have the crust. It's like the Earth's outer shell, solid and thin like an eggshell. The crust is where we live, where mountains rise and oceans lie. It is of two types based on what we see physically. The two types of craft are these: number one, the continental crust on which we live. Just have a glance on the ground you are standing. Yes, that is the continents. This is where the whole marine lives. Beneath the crust lies the mantle. It's much thicker and hotter than the crust. Think of it like a very thick pudding that flows ever so slowly. Deep down is the core, split into two parts, the outer core and the inner core. The outer core is made of molten metals. It's so hot that metals like iron and nickel melt like butter on a hot pan. Then finally, we reach the inner core. It's solid, primarily made of iron and nickel too. But why solid, you ask? Well, even though it's scorching, the immense pressure keeps it from melting like a secret treasure chest hidden deep inside the Earth. Have you ever marveled at what keeps you firmly on the ground? It's the Earth's gravity, a hug from the Earth. Many wonder if it all comes from a magic place within our planet. Well, it doesn't just come from one place but from the Earth as a whole. Interestingly, the Earth's layers contribute to its powerful gravity. The core, especially the dense inner core, plays a major role because it's so jam-packed with heavy metals. Now, what about those labels on the Earth's image? When scientists split the Earth into a model, they see each layer like a puzzle piece, each with unique properties and elements. How do we know all this? The Earth never lets us peek inside, but brilliant scientists have used clues from earthquakes and volcanoes. They study shock waves, like listening to echoes through the Earth, to understand its innards. So, next time you stomp your feet or stand tall on the ground, remember you are standing on top of an incredible, multi-layered marvel, teeming with hidden wonders just beneath your feet, fascinatingly waiting to be explored by curious minds like yours. Now, let's study deeply about each and every layer, their constituent elements, and their thickness. Now we're going to compare these layers with a giant cake. First, let's talk about the crust, the Earth's thin, outer shell. It's like the skin of an apple compared to the whole fruit. The crust is made up of two main types, the oceanic crust and the continental crust. The oceanic crust is like a thin layer of dark chocolate, rich in silicon and magnesium, which we call SIMA. It's heavier and denser. The continental crust, in contrast, is thicker, like a fluffy sponge cake, composed mainly of silicon and aluminum, known as SIAL. Beneath the crust lies the mighty mantle. It's the thickest layer, spreading from the bottom of the crust to the outer core. The mantle is not just one massive chunk, but divided into the upper mantle and the lower mantle. The upper mantle includes a special, slightly gooey part called the asthenosphere, which is vital for the movement of our tectonic plates, a bit like the sliding layers of a pizza. And then there's the hydrosphere, which isn't a solid layer. It's all the water in, on, and above the Earth. Think of it as the wonderful icing that covers our planet. It wraps around the crust, consisting of oceans, rivers, lakes, and glaciers, crucial for life. Digging deeper. Whoa. Do we reach the core? The Earth's core is like the giant iron marshmallow in the center of our planet. It's divided into two parts, the outer core and the inner core. The outer core is liquid and flows around the solid inner core. It's mostly composed of nickel and iron, known as NIFE, giving the core its name. This NIFE combination is what makes our Earth magnetic, just like a giant magnet lying inside. The movement of the liquid outer core around the solid inner core generates the powerful magnetic field, which shields our planet from harmful solar rays. Scientists believe that the inner core is growing gradually as the Earth cools over millions of years. Isn't it amazing how much activity goes on under our very own feet? Understanding these layers helps us appreciate the wonder of our planet, from the touch of soil on our feet to the unexplorable depths that lie beneath. So next time you step on the ground, remember there's a whole world underneath, full of dynamic and magical geological action. But is it so easy for the scientists to discover these all layers and study about this, or the scientists have just dogged the Earth from top to bottom? Well, the answer is no. Have you ever wondered how we know about these layers since no one can actually journey to the center of the Earth? Well, scientists have these amazing tools called seismic waves. You can think of seismic waves as secret messages sent by earthquakes that travel through the Earth, helping us understand what's inside. When an earthquake happens, it sends these seismic waves rippling out like gentle ripples on a pond. Special scientists called seismologists study how quickly these waves travel and the paths they take. It's like listening carefully to understand if someone is shouting from a hallway or inside a room. This helps scientists map out how thick and what different layers exist inside the Earth. Think of the crust as the Earth's skin, just like an apple has a skin. It's the thinnest layer, only about 5 to 70 kilometers thick, which is not much considering how big Earth is. The temperature here varies from 200 to 400 degrees Celsius. The temperature here depends on the depth. Beneath the crust, we dive into the mantle. This layer is much thicker, about 2,900 kilometers deep. The mantle is like a vast, thick soup of molten rock moving slowly and causing the crust to move. The temperature of the mantle is about 4,000 degrees Celsius, while the lower mantle 3,700 Celsius. Finally, core. The outer core is liquid and about 2,200 kilometers thick. Scientists find it fascinating because it's made of swirling molten metals. The inner core is even deeper and solid, with a thickness of around 1,250 kilometers. The temperature of the core is about 6,000 degrees Celsius. Now onto the exciting part, plate tectonics. Earth's crust isn't a single unbroken shell like a hard-boiled egg. It's broken into pieces called tectonic plates. Like a puzzle, these plates float on the softer mantle below them. But these aren't still, they move around. The theory of plate tectonics explains this movement. The planet's heat causes the mantle's material to move around, and, as the mantle moves, it drags the plates with it. Sometimes, these plates bump into one another or pull apart. Think of them like bumper cars or a magical dance. When plates push against each other, they can form mighty mountain ranges, like the Himalayas. When they pull apart, they can create deep ocean valleys or ridges. And when they slide past each other, they might cause earthquakes, the very events that send those seismic wave messages. By studying these waves, scientists not only understand Earth's layers, but also learn how our planet changes and shapes its surface over millions of years. So, next time you feel the ground shake, remember it's not only an earth-shaking event, but also a chance for scientists to peek into Earth's incredible secrets. Now, do you see this image of the Earth showing all the layers one by one? Yes, these are the layers of the Earth, which starts from the oceanic crust and ends in the inner core. For your exam centers, you can study this image of the Earth. Right in front of you is another image which you can use for your test and exams, which deeply shows the layers and their thickness. This is the image of the Earth's magnetic field, and which is mainly caused by the liquid outer core and its movement. Earth age, which is the big mystery for the scientist. Including the scientific consensus, the Earth's age being around 4.5 billion years. Have you ever wondered why the ground beneath your feet isn't just one large piece, but a collection of pieces? These pieces are known as tectonic plates, and they form the Earth's surface, called the lithosphere. So, let us learn deep or about the Earth's structure by learning the tectonic plates. Imagine the lithosphere as a giant jigsaw puzzle made up of several large and small pieces. These plates aren't just floating around. They're made of the Earth's crust and the uppermost part of the mantle, which are quite rigid. Beneath the lithosphere is the asthenosphere, a fascinating semi-molten layer that allows tectonic plates to move like they're riding on a slow, flowing sea. But why do these plates move at all? The Earth's interior is incredibly hot, creating convection currents in the asthenosphere. Think of these currents like a giant boiling pot where hot, less dense material rises while cool, denser materials sink, causing a circular motion. It's this motion that gives the tectonic plates the nudge they need to move. Tectonic plates don't all move in the same way. They have their own style. At divergent boundaries, plates move apart, making room for magma to rise and form new crust. This is how fascinating features like mid-ocean ridges take shape. Imagine a giant zipper opening up beneath the sea. Convergent boundaries are where plates collide. When one plate slides beneath another, it forms deep ocean trenches, majestic mountain ranges, and even fiery volcanoes. It's like two roads meeting and forming a mountain of adventures. Then we have transform boundaries, where plates slide past each other horizontally. Picture two cars grazing each other's side as they go in opposite directions. This sliding often triggers powerful earthquakes that shake our world. The effects of plate movement are nothing short of a dramatic geological show. Earthquakes occur when plates suddenly shift along fault lines, shaking the ground. Volcanoes erupt when magma finds its way to the surface, usually near plate boundaries. When plates collide and squeeze the crust upwards, majestic mountain ranges emerge. Even tsunamis, the fast-moving walls of water, can be triggered by this underwater activity. And if you have wondered how continents like Pangaea from millions of years ago drifted apart, shifting continents explain it all. The theory of plate tectonics is a pioneering discovery in geology. It provides a window into why our world looks and acts the way it does, from the formation of landscapes to the occurrence of natural disasters. Understanding this theory helps us trace our planet's history, answering questions about how Earth has evolved over time. Now it's time to wrap up information. Fascinated by these processes? Dive deeper into them, explore the wonders beneath your feet, and discover how these ancient movements shape our living world. Goodbye and happy learning! So this was the first video of my channel and I did a great hard work in it, and thank you so much for watching. And if you even once liked the video, do like, share, and subscribe. And do comments it helped you.